Hello friends, welcome to my channel. Welcome to Daily Code Challenges. Okay, today we have a very exciting challenge. But before we move to today's challenge, let's have a review of what we did yesterday. Yesterday we talked about least common multiple, also referred to as LCM, and we saw how we could write a function that could tell the LCM between two numbers. So we were able to write out multiples of the parameters and then find the common multiples and eventually find the lowest common multiple, which also is referred to as the least common multiple. All right, so let's move into today's challenge. I'm simply going to close this and also zoom this in a bit. All right, today's challenge is called is prime, and it says define a function is prime with a parameter number that returns true if number is prime, otherwise false. A number is prime if it's only divisible by 1 and itself. So we know that a prime number is a number that can only be divisible by itself and 1 without any remainder. So if a number exists and that number is divisible by 1, itself, and any other number, that number is definitely not a prime number. A prime number must only be divisible by 1 and itself only. All right, so let's see some examples of a prime number. We have 2. 2 is a perfect prime number. It's a prime number, right? Because it's divisible by itself and 1 alone. That also goes for 3. 3 is a prime number. 5, 7 is a prime number. 8 is not. 9 is not. 10 is not. 11 is a prime number. 13 is a prime number. 17 is a prime number. 19 is a prime number. 23 is a prime number. 29 also is a prime number. 31. 31 also is a prime number. Okay, all right. So let's stop at 29. Let me just comment this. How do we now implement this in code? First of all, let's think through this problem and see if we can actually have a way of interpreting the method to use to write the code. Firstly, we need to iterate from 2 to our argument whose parameter is called number here. Okay, let's just call this num. So when I'm using number and num, we understand that num is the parameter and number are just the numbers I am referring to in the series. All right. To work this out, we need to loop through from 2, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, down to 29. Now these numbers are just the natural numbers we have. We are not filtering them out, right? So this 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, down to 29. All right, that's established. Let's comment this. Then the next thing we want to do is that we are going to use this 29. 29, we divide 29 by each of these numbers before 29. So we stop at 28. That means that we divide 29 by 2, we divide 29 by 3, we divide 29 by 4, up to the point where we divide 29 by 28. If none of these numbers divide 29 without a remainder, that makes 29 a prime number, because that shows that 29 is not divisible by any of these numbers, automatically meaning that 29 is only divisible by 1 and itself only. right? For instance, let's assume our argument is the argument we passed in the parameter is 28. Let's divide 28 by every number in this series. The moment we divide 28 by 2, we know we get a 14. That automatically means that 28 is not a prime number, because it means that 28 is divisible by 1, divisible by 2, and itself. And also, of course, is divisible by other numbers in the series. But as long as it's not just divisible by 1 and itself only, it does not make it a prime number. All right, let's take it back to 29. So for the fact that every number here cannot divide 29, every number here cannot divide 29 without a remainder, that makes 29 a prime number. Excuse me. All right, so that's how we are going to be implementing the code logic. All right, here we start by writing the function keyword, and then we write the function name, which is called is prime. Then we place in the parameter. All right, this is established. Then the next thing we want to do is we need to look through the series. We need to look through the series between 2 to whatever the argument of num will be. So we say for, we use the for loop, and here we change index to I. We remove array.length, and also we remove this line of code. We don't need it. All right, so we loop from 2. That means that we change this initialization part. We change the 0 here to 2, and then we say I less than num. That means that we are looping from 2 to a number before num, if you get that gist, right? So that is what I actually explained here. We want to loop from here down to 28. That's if the argument is 29, so that we can divide 29 by all of these numbers. And if it happens that 29 divided by any of these, by all of these numbers, does not give a remainder, or rather gives a remainder, that makes 29 a prime number. All right, so let's console log the values we have in this series. We save this, and then we call the function name. We say is prime, and let's give it 29 as an argument. We save this, and then we run our code. All right, here we can see that this returned a series of numbers starting from 2 down to 29, which is what we just said here. Then 29 here will be divided by each of these numbers. Any number that divides 29, if any number divides 29 here without any remainder, that makes 29 not a prime number. That means that we return false, meaning 29 is not a prime number. But if otherwise, that makes 29 a prime number. So that's what we do next. Therefore, we simply, let's comment this line of code here. Then let's write a conditional statement. We say if parenthesis, curly brace. Now we say if num modulus I is equal to 0. This means that if num, which is 29 here, divided by every number in this series, if any one of them gives us, if any one of these numbers here divides 29 with no remainder, that makes 29 not a prime number. Therefore, we say return false. Let's take this out. That means it should return false. All right, so let's test with 29 and see. Let's see if 29 is a prime number or not. Let's run this. Okay, so this does not return anything because we need to console log the value. So we simply say console log is prime. We save this and we run again. It says undefined. Okay, that's undefined because we need to also give a second return statement. That means that for all of this for loop, if any of this, if the condition here is satisfied, this for loop code block should return false. Else, anything outside the for loop should return true. Let's see if this works. Let me run this and see. All right, so we get a true. It says 29 is a prime number. All right, so now let's also use numbers that we know that are prime numbers, really. So I'll simply just copy this, paste it in 5 places. We know 2 is a prime number. Let's leave this here. Okay, we know 6 is not a prime number. Let's add that. We also know 13 is a prime number. Then also we know that 20 is not a prime number. So we are expecting that this should return false, meaning is not a prime number. Sorry, return true. 2 is a prime number. This should return false because 6 is not a prime number. 13 is a prime number, true. 20 is not a prime number, false. 29 is a prime number, true. Here we are expecting to we are expected to have true, false, true, false, true. All right. I save that. I clear this console and I run this code again. Okay, so here we have true, false, true, false, true. Exactly what we have here: true, false, true, false, true. So here is how we write a function to check if a number is a prime number or not. I believe this was tricky and very interesting as well. So with this, we've come to the end of today's code challenge, and I'm so glad you're able to make it to today's live session. And also, thanks for coming. Thanks for having me as well. See you tomorrow. Bye.